I am already practice question in the course materials, so I'll show you in the screen. Give me a second.
Oh, okay, I just found it.
Got by? Okay,
Yeah,
great.
thank you.
Oh, girl. Oh, girl. Get your ass.
Okay, howdy. So let's start with the lecture with some announcements. So first announcement is that Sandbox tests uploading your multiple photos into a single PDF and upload it in campus. It is due tonight, right? So please test it so that, yeah, in case of quiz, I can recover your mistakes, but in case of the exam, I cannot recover your mistake upload on eCampus because it is all recorded in eCampus. So please practice how to make your multiple photos or multiple pictures into a single PDF and upload it on eCampus. So in the exam, it is exactly same as what you did in the Sandbox test. And I think that we have some echo. I hope in people in the online, can you hear me right now without any problem or is echo? Yes, just upload any pictures, but multiple pictures in one single PDF, which do not harm your privacy. Okay, and that's one announcement. Okay. Do you have any other question on this? And if you have any technical difficulty, please let me know. Okay, and the next one is quiz 3 is due tonight, and it will be given on eCampus, so you can see it after the class. And password is TSP. So just 3 letters with all lower cases. I will announce it after the class again using the email, but just let you know. And this quiz contains 4 problems, and you have 15 minutes to solve the problem. So I think it's not that difficult, but let's see. Okay. And the last announcement. Oh, do you have a question? Okay, got it. Okay. And last announcement is about the review material. So if you go to your eCampus, then from other new contents, you can see this review for exam 1. So here, if you just click review for exam 1, then you can see some handwriting problems. The reason I handwriting problem is that actually, yeah, I just literally just see my draft of the exam and just copy it with some changing. But I don't not have that much time to draw all the graphs using the computer, so that's why I do it. But please let me know if you have any trouble to read my bad writing. So for example, in the number 7, it is making 5-star, right? It is FAJITA. So yeah, there are some kind of typo or some kind of bad writing here, but I'm pretty sure that you can at least know what it means. So, but if you cannot, yeah, so I will make it a little bit polished version in the later today, but please let me know if you have any trouble to read it. And from the Zoom people, there are questions that do we use the Lockdown browser for the quiz 3? Yes, you need to use the Lockdown browser as you did in the previous quiz, right? Okay, and in the test of the eCampus, but you don't need Lockdown browser, but I will double check it again because I've heard that there are some system crash in the Tuesday of the next Tuesday from the eCampus IT team. So we need to check that whether we can actually do testing on eCampus or website. But yeah, but if there are no problems, then we will do test on eCampus without Lockdown browser. And I think that since we have 2 devices proctoring, so we don't need any Lockdown browser at this point. But if we cannot use the eCampus, then maybe we can use WebAssign. Then maybe you need Lockdown browser, but let's see. And I will let you know when I just got email back from my IT team, okay? Do you have any question, quiz, or test, or anything else? Okay, then. Oh yeah, there are some questions. Is the quiz over chapter 2 and 3? Oh, quiz is over chapter 2 only. So it asks you about the nearest neighborhood algorithm and sorted edge algorithm and some Kruskal algorithm and so on. So, and still, as you know, quiz is always open book, so you can see the lecture notes during your quiz, so you can do it well. And yeah, it's about chapter 2 only. And there are another question is that, can you please explain the sandbox PDF? So sandbox test is just uploading a single PDF which contains multiple portals. The reason we do such a sandbox test is that in the exam 1, you have some 5 problems. You need to take a picture and upload it. So, and to do this, eCampus only accepts a single PDF file as your answer. So you need to merge your portals into a single PDF file. So that's why I do sandbox test to prepare how can you combine all those portals into a one single file and upload it on eCampus. Does it make sense, David? Okay. Great. Yeah. So please do it before the tonight. And if you do the sandbox test, I will give you extra 5 points on the quiz at this quiz 3, right? So, okay. Do you have any other question? Great. Yeah. So let's get back to the list processing algorithm. Actually, I got some questions about the homework and the materials in this chapter 3 about this list processing algorithm. So I realized that my explanation is not good for explaining. So I will adopt some different type of explaining the list processing algorithm. So here I use the table whose one column is time and the other column is available processor and the last column is tasks which are ready, right? So since in case of the all jobs are actually dependent, then or we can do at specific time is some tasks which are ready. So let's using this table to make our processor things better. So the example 1.14 says that apply the list processing algorithm to diagram below with the priority list given, right? So the priority list is given by this. Okay, so the first question says that how long would it take with one processor? And it just asks about how much time we need to take to complete all the jobs, right? And the answer is just sum up or the task's completion time, right? Because in case when you use only one processor, then no matter how priority list is, or no matter how your schedule is, the completion time is always equal to the sum of all the task's completion time, right? What I mean is that you just did all the jobs by yourself without any helping, right? So in that case, it is 1, 4, 5. 1 plus 4 is 5. 5 plus 5 is 10. And so this part is just 10. And 2, 3, 1, 1. So this part 2, 3, 1 gives you 6. And 1 put 2 gives you 7. And this gives you 1. So it is 24 minutes. If my calculation is correct, but yeah, so that's you can deal with it. And next, how long would this take with two processors? And to calculate this time, we need to schedule all the jobs using two processors, right? So to schedule this using the list processing algorithm, first of all, you need to figure out which tasks are available at this point. So at the starting point, when time is just 0, at the starting point, the available processors are two processors, P1 and P2, right? So I just write down it here, P1 and P2. And here, from this dependency, only available job is T1, right? T1 is ready because all other jobs like T5 or T2 or whatever except T1 requires the first job should be completed, right? Because of these arrows, right? So all you can do at this point is T1 only, right? So according to the list processing algorithm, you need to assign your T1 into the processor 1, right? So just write down T1 into the processor 1. And in that time, processor 2 is just wait, right? So it is idle time. And T1 takes only 1 minute, so that's done. So after 1 minute, T1 was done. Then still there are two available processors, P1 and P2, right? And then there are two, you already done T1. So T1 was done. So now we can do T5 or T2, right? But from the, so T5 or T2 are available. But from the priority list, we know that T5 is just third rank, right? But T2 is just second rank from the bottom. So definitely T5 is much more important than T2, right? So in that case, you need to assign T5 into the first processor and you assign T2 into the second processor, right? So in that case, just assign T5 in the first processor and T2 in the second processor. And T5 takes 4 minutes and T2 takes 5 minutes, right? So this is the time. So after 4 minutes from the 1 minute, which is 5 minutes, then your P1 just complete the T5, right? Okay, do you have a question? Because that in the at the starting point, T5 requires to T5 ready, you need completing T1, right? But T1 is not completed at the starting point, so that's why we need to make P2 just ready. So that's why we have either in the P2 at the starting point. Mhm. Could you repeat again your point? Mhm. Mhm. In order to do T2, we need to do T. You're right. Sorry. So, so what she pointed out is this line. Actually, that's what I forget. Because yeah, from this line, thank you very much. So T2, if we want to do T2, then we need to complete not only T1, but also T5, right? That's your point. Oh, thank you very much. Yeah, I forgot this. So in that case, yeah, definitely we cannot do T2 at this point. So you already have T5 here. So still T2 is either. Thank you very much. Thank you. Okay, sorry for mistake. Okay. So now after the 5 minutes, T5 and T1 are done. So now there are 3 candidates, 3 jobs are ready, which and T2 is ready, and T6 is ready, and T7 is ready, right? So here we have 2 available processors and 3 jobs, T2, T2, T6, T7, but from the priority list, T6 is the most prioritized one, and T7 is the next one, and T2 is the last one. So we just change it each order using this priority list to say T6 as the first, T7 as the middle, and T2 as the last one. And then you can assign T6 for P1 and T7 for P2 to do the job. Then T6 should be in P1 and T7 should be in P2. So T6 takes 4 minutes. So it ends at 9 minutes. And T7 takes 2 minutes. So it ends at the 7 minutes. So after 7 minutes gone, then what you have a better processor, P2. P1 is still working on T7, T6, and then you finish it T7 already, but still, then all your available job is T2, right? Because T2 is already available from the 5 minutes, so T2 is also available. And T8 requires T6 and T7 was completed, so we cannot do T8 at this point. So only ready task is T2. So just assign T2 on processor 2, right? Then you can put T2 in here. Okay, and then T2 takes 5 minutes. So from 7 minutes to 5 minutes, you can complete T2 at the 12 minutes gone from the initial point, right? Okay. couldn't we do T8 first? No, because T8 requires to complete T6 and T7 both, but still we are working on T6 at the point in 7 minutes gone. So that's why we cannot do T8 at this point. Does it make sense, Gunnar? Great, yeah. Okay, then after 9 minutes, now processor 1 is available, right? But processor 2 is working on T2, and we just finished T6, right? Okay, sorry. So from this, now we can do T8, right? Because T2 is still working on, so only ready job is T8, so assign T8 into processor 1, and T8 takes 1 minute. So after 1 minute, at the time 10, then still P1 is available. So still P1 is available, and you already finished T8, so you can do T8. But in that time, T10 requires the completion of T9 and T4, which we didn't do. So there are no available job until T2 was done, right? So there are no available job. Hence, you need to make P1 idle until T2 was done. So here is the 12 minutes. Does it make sense, or do you have any question before going further?
So it's okay to make processor 1 idle if that's all you can do.
Yes. So if there is no job which are ready, then you make your processor idle. Yeah. Is everything good? Great. Then after 12 minutes, now both processors are available, and we finished it. T1, T2, T5, T8, T6, T7, T8, right? So currently only ready job is T3, right? Because T10 still required to finish T9 and T4. So only available job is T3. So just assign T3 onto the processor 1, and it takes 2 minutes. So in that time, just make process 2 be idle. Just let the process 2 wait at this point. Okay, so, and after 2 minutes, so at the 14 minutes gone, then T3 was done. Then still P1 and P2 are available. And then what you can do is T4 and T9, right? Because T3 was completed. So here T4 and T9 are available, but from the priority list, T4 is the second one, but T9 is something in the middle. So T4 is much highly prioritized than T9. So we need to assign T4 into the processor 1 and assign T9 into the processor 2. And T4 takes only 1 minute, and T9 takes 3 minutes. So it is 17. So after 1 minute, okay. Yes. So the question from the Zoom is that why couldn't you just assign the next task instead of idling? And as Purcell answered, because the next task can't be completed until the prior task is done. So for example, in T3, we cannot just assign T4 and T9 to processor 2 because T4 and T9 needed to completion of the T3. But T3 was working on by processor 1, so that's why we give some idle time to processor 2. Does it make sense, Hannah? Great. Okay, so at the time 15 minutes, so after T4 was completed, still there are only left job is T9 and T10, but T9 was worked by processor 2, and T10 equals the completion of T9, so there are no available jobs. So here P1 is still available. So in that case, we just give them some idle time. And after 17 minutes, then P1, both P1 and P2 are available. And the only remaining job and ready job is T10 because T9 was also completed by processor 2 at the 17 minutes. So at this point, the only available job is T10, so you can just assign T10 into the processor 1. Oh, sorry. And make T10 takes only 1 minute and make an idle time. So, and after completing T10, all the jobs are done. So how long would this take with 2 processors is 18 minutes, right? So does it make sense for making table? Okay. So I'm not sure, which method are much more easier for you, but I think that at least making table, you can avoid the mistakes. So that's why I put it here. And from the question from June is that, so why did I use T6 and T7 if T1 and T5 were completed? So could you make your question more precise, Joanna? Because I
Yeah,
just,
can you hear me?
pardon?
Can you hear me?
Yes, I can hear you.
Okay, I was just wondering because you had already completed T1 and T5.
Mhm.
Why didn't you use T2?
Okay. So the reason is that there are 3 jobs here, right? After 5 minutes, there are 3 jobs available, T6, T7, and T2, right?
Yes,
Okay. But when you see the priority list, then T6 was the most prioritized one.
got
Then
it.
T7 is the next one, and T2 is the least prioritized one, right? So that's
Gotcha.
why we just do T6 and
All right,
T6.
I missed the list. Thank you.
No problem. Great. But that's a good point. Yes, sometimes as I did earlier, so you can do the mistakes. So yeah, always remember the prioritized list. Okay, do you have any question on this? Good. Okay, then the last question is, what is the optimal time for completion of job depicted in this graph? So in this graph, to get an optimal time, you need to get the critical path, right? So here, from the picture, definitely critical path looks like using this, but you can make it more complicated. So maybe if you just test it, then the critical path is T1 to T5. Is it T5? Oh yeah, T5. Thank you. And T2 to T3 to T9 to T10. And it takes 5, 10, 15, 16 minutes. 16 minutes is the optimal time for completing this job. Yes. Yes, it is the longest chain from left to right. Yes, so as you just traverse your graph from T1, T5, T2, T3, T9, T10, then it takes the longest time in the whole graph, right? So
And that's
basically,
the critical path, right?
yes, that's the critical path. Yes. So the optimal time for completion of a job, which is dependent, is the same as the length of critical path, right? Great. Do you have any other question? Good. Okay, so let's deal with the same example, but in case of 3 processors. So again, here we can, instead of doing everything we can maybe just copy this and maybe you can use this one as a kind of reference. Oh my God, how can I copy it? I don't know. Okay, so let's deal with this without here. So, okay, here first time at the time 0, yeah, the available process is already P1, and there are 3 processors, P1 and P2 and P3. So here, since T1 is already ready to job, so we can just assign T1 into the processor 1 and make all others idle. And after 1 minute, now again, here already ready to job is T5. Yes, so here also you can assign T5 into the P1. So here T5 and T5 takes 4 minutes. So you can read other processors wait. Okay. Then after 5 minutes, T1 and T5 are done. So the available jobs are T6, T2, T6, T7, and from the priority list, T6 is the first one, and T7 is the next, and T2 is the least prioritized one. So in that case, we can assign T6 to processor 1, and T7 to processor 2, and T2 to processor 3. So here T6, T7, and T2, and T6 take 4 minutes, and T7 take 2 minutes, and T2 take 5 minutes. Right, so here is 5, here is 7, 9, 10. And at the 7 minutes, now T7 was done, but still the other processor working on T2 and T6, and T8 requires the completion of T6, so there are no available jobs or tasks, so just make the processor idle. And after 9 minutes, now P1 and P2 are available, but and when in here T6 and T7 was done, So now there are ready to job, which is T8, right? So you can assign T8 into the processor 1 and make P2 still waiting. And T8 takes only 1 minute. So here is done. And after 10 minutes, now all processors are available. And we did T2, T6, T7, and T8, right? So here, only ready to job is T3 because T10 requires to complete T9 and T4, right? So just assign T3 into P1. It takes 2 minutes and make other two processor wait. Then again, after 12 minutes, now T3 was done and the ready to job are T4 and T9, but from the priority list, T4 has higher priority than T9. So yeah, assign T4 to processor 1 and assign T9 to processor 2, T4 and T9, and make processor 3 as wait. And T4 takes only 1 minute, 13, and T9 takes 3 minutes, which is 15. And after 1 minute, T4 was done, but still T10 is not ready because T9 was not completed. So we need to make both processor P1 and P3 as idle. And after 15 minutes, now T9 was done. So here is no available job. And after 1 minute, after 2 minutes, at 15 minutes, now T10 was ready and all 3 processors are available. So you can just assign T10 into the T1 and it takes 1 minute and everything is done. And this process takes 16 minutes, right? I didn't make any mistake, great. Okay, so, okay, do you have any question on this process? I did a little bit quick, but it is basically the same process, right? Are you okay with it?
So how would we test it on something like this?
In the test?
Yeah, like are we gonna have to
Yes, so in the test, so this one actually something you need to draw on your paper and take a picture. Yeah.
So, excuse me, I have a question. So that table that you wrote to the side, we have to put that on the test even if we don't need it?
So in the test, you don't need to put this side table on your answer. So all I need to ask is about this original table about schedule.
Okay,
Well,
I just wanted to know if we needed to do that stuff to the right.
Oh, great. Yeah, you don't need to do that because in the original, lecture note, actually this side table was not needed, but in the last time, I just got so many questions about the schedule, so that's why I made this one for your understanding, but you don't need to write down it as an answer. Only what you need to do is just making this schedule table, okay? Do you have any other question? Good. Okay, so this 1.16 is the same, but with the different processors. So I will leave it as an exercise, and I will provide an answer after the lecture. So you can just check the lecture note maybe tonight to see the answer, but I just want you to practice your knowledge about the list processing algorithm in this example, because in the exam, there is something very similar on this example will come up. Okay, And this one is also very similar to one of the exam programs. So let's see the example 1.17. So it is about the launch. So from this list of tasks, first of all, we need to draw a diagram showing dependency of the task below. So from this, first of all, finding lunchbox need not any prior task. So T1 may be just starting point. Oh, and it takes 5 minutes. So we need to draw 5 with T1. And T2 is just clean lunch boxes, but you cannot clean your lunch boxes until you have lunch box. So definitely T2 requires the completion of T1. So we have this dependency from T1 to T2. And next one is T3. And you can make sandwich without lunchbox. So T3 should be one independent of T1 and T2. So you can just write T3 below of T1. And you can wrap your sandwich only if you already have a sandwich. So T4 is definitely dependent on T3. So you need to add some arrow from T3 to T4. And again, you can wash your apples without sandwich or without boxes. So T5 is independent of prior jobs. So you can write down T5 in the below T3. And you can also put chips in the bag without washing apple or making sandwich or finding lunchbox. So T6 is also independent one. And also you can get drink without any of prior jobs. So you can get drink. And pack or lunch boxes needed all these kind of jobs. So it is kind of final jobs. So you need this T8 is dependent for every other 5 jobs. Right. Okay. Yes, something similar will be on exam. Yeah. So kind of making diagram and find the schedule. Okay. So graph looks like this. And what is the optimal time to complete this process? It is just the ranks of the critical path. And from this, you can see that there are at least 5 phases starting to T1 and ending at T8, or T3 to T8, T5, T8, T6, T8, and T7 to T8. But if you just calculate the ranks, then 5 plus 3 is 8, 7 plus 2 is 9. So this one has the most longest ranks. So the critical path is T3 to T4 to T8. And it does optimal time is just length of critical path, which is 9 plus 4, which is 17 minutes. Okay. Is there any question before going further? Good. Okay, great. And then next one is using the given priority list to schedule to process to complete job, right? So first of all, we have 2 processors, P1 and P2. And again, we have priority list here. So at the starting point, we have 2 available processor, P1 and P2. And the jobs already is T1, T3, T5, T6, and T7, right? But from the priority list, T7 is the most higher one, and T6 is the next one, right? So here, only these two are most higher one and the next one. So just assign T7 into processor 1 and assign T6 into processor 2, right? Then T7 in the processor 1, T6 in the processor 2, and T7 only takes 1 minute, and T6 takes 3 minutes. So after 1 minute, processor 1 is available, right? Because processor 1 just complete the job on T7. So T7 is not available. So here, and T6 is worked by T process 2. So the only available jobs or only ready jobs are T1, T3, T5. Does it make sense? Or do you have any question at this point? Good. Okay. Great. Then here again, using your priority list, T3 was the most prioritized one in this list. So you need to put T3 into the processor 1. Okay, so here, and T3 takes 7 minutes, right? So it's 8, and it ends at the 8 minutes after. So, and after 3 minutes, now processor 2 complete the job T6. So here, what we can do is available processor is P2 and ready job are T1 and T5 because T3 was worked by P processor 1 and 7 and 6 are already completed. And also according to the priority list, T1 is much more prioritized than T5. So you need to put T1 onto the P processor 2. So here T1 and T1 takes 5 minutes. So 1, 2, 3, 4, 5. So after 8 minutes, now you can also complete T1 and T3. And after 8 minutes, two processors, both processors are available. And the ready job at T1 it was done, T3 was done. So T2, T4, and T5 are available. And from the priority list, T2 was the highest priority among those three. So you need to put T2 on processor 1. And next, T4 is the next higher priority. So you need to put T4 into the processor 2. Then here T2, here T4, and T2 takes 3 minutes and T4 takes 2 minutes. So 11, 10. So after 10 minutes, processor 2 is still available. And their ready to shop is just T5. So assign T5. And after 11 minutes, there are no available jobs. So because T5 is worked on by processor 1, processor 2, and the only left job is T8, but T8 is ready when all other jobs are done. So just put idle, and the remaining job after 12 minutes is just T8 only. So you just put T8 on the first processor to get the answer, and it takes 4 minutes, 16, and process 2 should be idle, right? Okay. Okay. Does it make sense? But do you have any question? Could you speak on? Oh, Zoom, okay. Is it good or do you need more time? Good. Okay, then next one, I will give it an exercise and I will provide an answer tonight. And also example 1.18 is exercise because it is definitely the same one. So let's deal with the critical path scheduling. So as you know, in the previous example, the priority list was already given, right? So it is fixed from some, other ones. But maybe this priority list is not reasonable since it doesn't consider about the critical path, right? So to make schedule much more optimal, we just adopt the method of how to make a priority list using critical path. And it is called critical path scheduling. So critical path scheduling is just make a prioritized list from the critical path, right? So to do this, first of all, definitely you need to find the critical path in your diagram. And maybe you have one or two more critical paths, then in that case, just choose the lowest task numbers. So at least you just have only one critical path whose numbers are all lowest. And if you make a critical path, so for example, in this example, critical path should be T3, T4, T8 because 7 plus 2 is 9. Or 5 plus 2 is 8, so 9 is much more greater. So I think T3, T4, T8 is the critical path. So if you find the critical path, then just put those tasks as the priority list first. So T3, T4, 8 is the first things you need to you need to put in the box of priority list. Then remove those T3, T4, and T8. And again, you can just find another critical path. So here, T1, T2, and T8 is another longest path, right? Except the critical path.
Professor,
Yes?
but for the critical path that involves T3, T4, and T8, shouldn't T6 be part of it too?
T6 is not the part of the critical path because the arrow of T6.
I saw the arrows the wrong way. I'm sorry. Never mind.
No problem, no problem. It's okay. Good. Yeah, because arrows is actually not from T8, but from T6. So that's why we didn't use T6 in the priority critical path. So, okay. Sorry, I had a mistake. Yeah. What I did, so if you find the critical path, then only put the first task in the priority list. Sorry, not the order task. Yeah, T3 only. So in this case. So the critical path is in here is T3, T4, T8. So just put T3 only. I'm so sorry. Yeah. And after that, just delete T3, then find the critical path again. Yeah. So find the critical path again, then you can find T1, T2, T8 as your critical path. So again, put T1, which is the starting point of your critical path, in the priority list and delete T1. Then again, you can find the critical path. And here you can find two critical paths, T2 to T8 or T6 to T8. But T2 is definitely lower task, right? The lower number of tasks. So just pick T2, T8 as your critical path and put your T2 into priority list and delete T2. Then again, from T6 to T8 is the critical path because T6 is the 3, which is the greatest number among all other tasks except T8. So just add T6 into your priority list and delete it. And the next one is T4, T8 is a critical path, and T5, T8 is also critical path, but T4 has lower numbers, so just put T4 into your priority list and delete. And next critical path is definitely T5, T8, so just add T5 into your priority list and delete. And now T7, T8 is your critical path, so just add T7 and delete. Then all remaining number is T8, so here lastly at T8 you are done. Sorry for confusion for the first time. So yeah, so what we did is just make a critical path, just the first task of your critical path into put your first task of the critical path into the priority list and delete that task and find the critical path again and put the first task in the priority list and delete that task and so on. So repeat this process to find the priority list, right? So this is the critical path scheduling. Okay. Do you have any question on this scheduling? Good. Okay, then let's deal with some other critical path scheduling from below diagram. Actually, this is the similar diagram. So here, first of all, we know that critical path is this long one, right? T1, T5, T2, T3, T9, T10, right? So here again, put T1 in the priority list first and delete it, right? So if you delete, then next critical path is still, it starts with T5 and go to here, right? So because, you know, if you just add something, yeah, then still deleting T1 already reduce 1 minute from your critical path, so it doesn't contain any other passage as your longest one. So again, here you can put T5 and delete T5. Then now your graph only needs this part. And from here, yeah, if you just look around, then still starting T2, T3, T9, T10 is the critical path. So just put T2 into next one and delete it. Then after deleting this one, we need to deal with carefully. So first route, T3, T4, T10 takes 6 minutes. And second route, T3, T9, T10 takes 6 minutes again. And third route, T6, T8, T10 takes 6 minutes. And fourth route, T7, T8, T10 takes 4 minutes. So these all three colors, like green, blue, red, give us the critical path, and their first task is T3 or T6, right? But in this case, we promise that we just put the lowest number of tasks first. So just put T3 into your critical priority list and delete it, right? So now we delete T1, T5, T2, T3. Then again, this green one just take 2 minutes, and this blue line just take 4 minutes, And still, this red line takes 6 minutes, so it will be critical path. So add T6 into your priority list and delete T6. Then we delete T1, T5, T2, T3, T6. So this green one takes still 2 minutes. And this blue line takes 4 minutes. And the red line, now starting from T7, also takes 4 minutes. So we have starting point is T7 or T9, but from the process, we already take the lowest number first. So just put T7 in here and delete T7. Then we just delete all these things, and all we left is this 2 minute way from the grain and 4 minutes from the T9 and 2 minutes from T8. So T9, T10 is the critical path. So you need to adopt T9 as the next member of your priority list and delete it. And lastly, not last. So here we have T4 and T8 and T10, but you know that T4 to T10 takes 2 minutes and T8 to T10 takes 2 minutes. So both are the critical paths. So you just adopt T4 first and delete T4. Oh, sorry. Okay, great. Then the remaining one is T8, T10. So you just put T8 on your priority list and T10 in the priority list, then you're done. So that's the completed one. So this one is very difficult one. So in the exam, maybe some simple graph will be given to find the schedule, find the critical path scheduling. But okay, do you have any question? Good. Great. Yeah, so this is about the critical path. And now we are dealing with beam packing. So beam packing problem is basically we have some, some kind of stuffs like some weights, and we have boxes which can carry some fixed weight. So for example, when you read example 2.1, we have some boxes available that holds almost 10 pounds, and you have items with weights very different numbers, right? Then we want to use the fewest box to packing all the items, right? So that's the beam packing problem. And there are 4 algorithms can be introduced. So first algorithm is about the next fit algorithm, right? Next fit algorithm is just put items into open bin until the next item will not fit. And if you see the next item is not fit, then close that bin and open a new bin for next item. So let's do it this process. So first item is weight 5, and we know that box 1 carries 10 pounds. So you can add your 5 one, right? So write 5. 1, 2, 3, 4, 5, 7, 8, 9, 10. Okay, good. 6, 7, 8, 9. Oh, I need one more. Yeah, I need one more, right? Sorry for mistake. Yeah. And next item is 7, right? But you cannot put your 7 onto the box 1, right? Because in that case, 7 plus 5 is 12, which cannot be carried by the bin, right? So in that case, just say close and put your 7 onto the other item, other box, right? And next item takes 2 pounds. And you can put your 2 pound item onto the second bin because 2 plus 7 is 9. Still, your box can carry the 10 pounds, right? So you can put your third one into the second bin. And the next one is take 6 pounds. And definitely you cannot put your 6 pound one into the second bin. So just close this second bin and put it into the new bin. And again, you cannot put your raise 5 item into the third box because 5 plus 6 is 11, which exceeds the 10. So again, you can close your third box and open your new box and put it here. Then next item is 1, so you can put 1 onto your fourth box. And also you can put your 3 onto your fourth box, but you cannot put your 4 item into the fourth box. So again, close it and open a new box. Then put your item with weight 2 into the new box, box 5, and put item 3 into the box 5. But you cannot put your item with weight 6 into the box 5 because it already has 9 weights. So close the door and put other box, which gives 6. And last item takes only 3. So you can put it into the box. So using next bit algorithm, you can use the 6 boxes to packing all the items, right? Does it make sense? Do you have any question on next bit algorithm? Great. So as you can see, there are some, it is not that efficient, right? For example, you can see that some open spaces here from box 1 and box 3. So the next algorithm is actually a little bit better than next bit algorithm. So it says its name is first bit algorithm. And it says that put items into the first already open bin that has space for it. So if no open bin has space, and open a new bin. So for example, again, the starting one is 5, so you can just put your 5, the first item into the open box. So into the first box. So 1, 2, 3, 4, 5. So your 5 should be in the 1. And again, since you cannot put 7 item 2 into your box 1 because 7 plus 5 is 12, which exceeds 10. So you need to put 7 into the second box. So that's the same with the next bit algorithm. But in case of 2, we notice that actually both box 1 and box 2 has a space, right? But therefore, just put your the third item into the box 1 because box 1 has open space for item 2, right? So that's the difference between first bit algorithm and next bit algorithm. And again, for 6, you need to open new box, box 3, because you cannot put 6 on the box 1 and 2 because of exceeding the number. And again, for for fifth item, it takes 5, weighs 5, so you need to put open box in here. And next one, it has only weight 1, so again, you can put your item with weight 1 into the box 1 because box 1 has space to store it, right? Does it make sense, or do you have any question? And next item has weight 3, but you cannot put weight 3 into box 1 because, if you add every number and 3, then you can get 11, which exceeds 10. But you can put your 3 into box 2 because 3 plus 7 is 10, which is just the limit of the box, right? So you can put your item with weight 3 on the box 2. And again, you can put item with 4 in the box 3 because 4, 6 plus 6 is also 10, which is just the limit, right? And 4 cannot be into the box 1 because it exceeds the limit of the box. And next one is 2. So there are 2 open box, box 1 and box 4, but you can put your 2 onto box 1. So just put it in the box 1. Then box 1 is also has a limit. 5 plus 2 plus 1 plus 2 is just 10. So now all 3 are closed at this point. And you can put your item with weight 3 into the box 4. So here I just write a little bit smaller. Yeah. And again, next one is 6, but you cannot put 6 on the box 4. So you need to open one of the new box and put your item with weight 6. And then the last one is 3. And 3 cannot be put into box 4 because 3 plus 8 is 11, which exceeds the 10. So you need to put 3 into the box 5 to packing all items, right? So here we use only 5 boxes, but in the next speed algorithm, we use 6 boxes. So definitely per speed algorithm gives the optimal one in this case, right? Okay, do you have any question? Okay, great. And next one is called worst fit algorithm. So in this case, put items into an already open bin that has the most space over it, for it, right? So in case of the first fit algorithm, we just put the item into the lowest numbered box if it is available, right? But in case of worst fit algorithm, we do not only just put it on the open spaces box, but also checking the spaces, the open one, and put it in the most open one, right? What I mean, put it in the most space for it, right? So let's try to give it an example. So as we did already, so first 2 items are same because 5 and 7 cannot be into the same one, and next 2 should be into the box 1, not because box 1 is just the first one, but because box 1 has space 5, instead box 2 has space 3, which is smaller than box 1, right? So we just put our third item into box 1, and again for 6, you need to adopt 6 into the new box because you cannot put it into box 1 or box 2. And also in case of 5, you need to put another box open another box because you cannot put 5 into box 1 or 3. And again, for item with weight 1, here box 1 has space 3, and box 2 has space 3, and box 3 has space 4, and box 5 has space 5. So box 4 has the most space for the item with ray 1, so just put it into box 4. So now it has space 4. And for next item, yes, box 3 and box 4 has the most space for it, right? So in this kind of tie case, just put it in the lower number box, which is box 3. Then box 3 now has space for only 1. Then the next one is ray 4, and only available box is the first one, because box 4 only has the space with 4. So now it is closed right now. And okay. And next one is 2. And again, box 1 and box 2 has space 3, which are tied. So just put your 2 into the box 1. And for 3, box 2 has space 3, and the other boxes do not have space much for 3. So put this 3 into box 2. And for 6, just open new box. And here box 4 has space 4. And for numbers last item, the box 5 has the most space for it. So put it into the last box. Right? Okay. So that's the worst fit algorithm. And best fit algorithm is the same, but put it into item with the least space for it, right? So because of time, I will just stop here, but I will write down with explanation on this lecture notes. Sorry for exceeding some times, and please let me know if you have any question. Okay. So quiz password is TSP. Okay. Yes, it's by midnight. Yes. Thank you, Morgan.
I was trying to do
Yeah,
the.
quiz cover chapter 2. Okay. Okay. Do you have a question?
I was trying to do the sandbox thing, and it won't let me upload my PDF.
Oh, okay. Give me a second. What is your name, Joanna?
Yes.
Yes, but I will let you upload it again so that don't worry about that. Yeah. So I check it. So
Well, it let me open it, but it won't let me upload anything. If I click on it, it just sits there.
okay, give me a second. I will check the availability for this. Okay. So are we in section 503, right?
I think so.
Okay, yeah. I think it is still available, and I allowed unlimited attempts, so I think that you can do it.
If I click the browse my computer button, it won't do anything. It just doesn't activate. So I don't know if it's a problem with my computer or what.
Okay, so then let's do it. If you do you have maybe 5 more minutes, then maybe we can do it with using sharing your screen into Zoom. So
Oh, okay.
yeah. Okay, give me a second. Okay, so what is your case?
So I just want to clarify, we have the quiz due tonight on chapter 2,
Mhm.
right? And you said these are notes for that?
Yeah, you can use the lecture note. Yes,
Okay.
if you open book quiz, yes.
Okay. And does that use a lockdown browser? Or no?
Yeah, it uses lockdown browser.
Okay, but like I can pull up the notes on my like my iPad or something.
Yes, you can put up your notes on iPad or some cell phone. Yes.
Okay. Then the exam review you gave us isn't for this. That's for like the exam later.
Yeah, exam review is for the exam 3, which will be held on the next Tuesday.
Okay.
So it is not about the peers. Yeah.
And then what pictures do we upload for the sandbox thing? 'Cause I understand
So
we're
any
practicing it.
pictures which you do not harm your privacy is okay.
Okay,
But just taking several pictures, not one picture.
okay. So just to practice putting them all in one PDF.
Yes.
Today as well.
Yes, you're right.
Okay, thank you.
Thank you.
Have a
Mhm.
good day.
No, have a good day.
So I just want to make sure,
Mhm.
so the exam is Tuesday, so don't come here.
Yeah, don't come here. Yeah. I will give some announcements to don't come here. Maybe just find some place which Wi-Fi is good and you can proctor yourself using cell phone. Then yeah.
So like we'll do the exam on the computer and like use the cell phone to go to Zoom and that'll help see how we like practice.
Yes, you're right. Yes.
And so, well, I guess is it best to just like pop the phone, like get some books or something so we can like see us at the computer? Is that
Yes. So you make your cell phone watch you and your desk and your computer in the 3 times. Yeah, then that's okay. Yeah, we don't need lockdown browser yet, but I will check it double check it to IT. Okay, thank you. Have a good day. Okay, Joanna, could you share your screen if you don't mind? I will let you share
Sure.
your screen.
Okay. It's not letting me share my screen for some reason. I don't know why.
Okay, give me a second.
I think it's on my end. I think it's my privacy setting. Hang on just a second.
I have a quick question. Have you already opened quiz 3 yet?
Is it working? Is it showing my screen? I think it is.
Okay, go to campus, please.
Ah,
Oh yes, so here you can see the browse my computer button, right? Can you see the browse my computer button? Can you
oh
hear?
yes, but it won't let me click on it. It doesn't let me do anything.
Or so can you click the browse content creation instead?
No, I can't click either one of them.
Oh, okay. Then could you just do it again by closing your Safari and deleting all of the browser history, and then I think you'll work.
Oh, okay. I'll try that and I will email you again.
Yeah, okay, great. Thank you.
How do I get out? Oh, stop sharing. Thank you.
No problem. Have a good day.